like to welcome everybody here to our ISU Dairy Team webinar series here in January. Uh, our speaker today is Dennis Todey. Dennis is with the Weather Hub. Probably one of the people that really needs no introduction. I think he's recognized in half a dozen states up here in the upper Midwest. Dennis, we're looking out the window. We're starting to see a little snow now up here in Northwest Iowa. Uh, what's your thoughts on, on this superstorm that's going to be coming through?
Well, see, our problem is we've had these supply chain issues with moisture. We're getting the moisture to you just several months later than you really wanted it to happen. So,
Yeah, and two
uh,
trucks at a time.
two tricks. It's the Sam's Club version of you can have all the moisture you want, but it's coming at once, just like we're
There you
given
go.
California right now. So now, Fred, you said I was recognizable in a lot of states. Now, maybe some of the people in those states don't want to say they recognize me. Oh, it's that Toddy guy. That's a problem. So
Yeah.
anyway, thanks, Fred. Appreciate having me here. And yes, from a current weather standpoint, when we're recording this, it's January 18th, and we have a pretty large storm system coming over us right now that is starting, well, it's producing problems out of Nebraska immediately. Right now with some fairly heavy snow and some decent winds along with it. That's going to be moving over Iowa as the afternoon continues and into the evening hours. It will continue into the early morning tomorrow across northern Iowa. Southern part of the state is, especially southeast, is mostly going to stay as rain or a mixed bag, so not too much accumulation. As you get into the middle part of the state, say, from Atlantic to Des Moines to Waterloo, there's going to be a mixed bag and probably some snow accumulation, but total amounts are a little bit in flux depending on how much falls as mixed precipitation and how much falls as snow. Then you get up into northwest Iowa, you know, there's always a range on this because there's a lot of things that influence how much snowfall falls, and sometimes you get some locational issues, but there will be, multiple inches of snowfall, 6 to 8 to 10 in some places. This all ends up being from a summary standpoint helpful because it does provide moisture for us. The downside is it's not as helpful as we need it to be. 'Cause we'll talk about this as we go along. We get some frozen soils issues. So it's, for anybody who's catching this still on time, certainly don't want to be, people want to be taking great care if they have to be out driving around in this or postpone travel if at all possible. Okay, so what we're going to do is kind of give you a quick update on conditions right now and where we're going to be headed. Also going to drop a couple new tools that have come out in the last year that people might find some valuable and have some interest. So just a reminder of who we officially are. We're part of USDA, we sit at the National Laboratory for Agriculture and the Environment, which is part of the Agricultural Research Service, part of USDA. Sit on campus at Iowa State. We officially cover the 8-state region, Minnesota, Missouri, over to Michigan and Ohio. But then we do connect with surrounding areas because of our row crop background. We work with folks, the regions in the Northern Plains on a cropping standpoint, and even down in Kentucky because of some other connections down there. So regional, working basically with a wide range of climate issues, and agriculture is what we do, even livestock kinds of issues. So if you have more questions about that, please feel free to ask at any point and reach out to us. Okay. First tool before we get into current conditions, wanted to roll out this year. Some previous years we've talked about changing climate issues and some of the issues related to agriculture, and we're able to point out. I should also add before I go further, almost everything in this slide set is from a publicly available website. So I am happy to share these slides. You can have the links to the various places of information. You can make a number of these graphics for yourself to be able to show, or if you want to show a regional audience or a local audience, some of these issues. So we're happy to share them. One of the issues we've had, and we know is going on, but we weren't able to quantify as well, was our changing freeze frost dates in the spring and the fall. Generally we know that this last spring freeze is getting earlier. Generally we know the first fall freeze is getting later, but it was hard to put numbers on that and get a good local look at that. Um, let me jump ahead a couple slides. This was a graphic from the last National Climate Assessment at that, giving you a view nationally as to how long our frost-free season period or how that was changing over the last century, essentially. And it's saying Iowa and most of the Midwest and the Upper Plains was 9 to 10 days. Okay, but that's a very broad number. So we wanted to give something a little more local, a little more, give people an opportunity to see it in a little more detail. So we partnered with another entity called the Midwest Regional Climate Center. They are funded by NOAA, National Oceanic and Atmospheric Administration, to work on climate data, climate tool issues, some agriculture, but a wide range of other issues. We've known them well and said, hey, we got this idea. Can you work with us? And they were able to help us, and we went back and forth a lot on how this worked, how it would work the best, and really happy with something we came up with. And the website is down there below. MRCC is at Purdue University, and it's a freeze date tool. And what it allows you to do, and the graphic that it shows here, is it allows you to when you go in, you'll see this map that looks like this, and you see all the counties in the upper Midwest, and it even extends out to the Northeast. I don't know if anybody from the Northeast will be watching this, but it extends out to that area too. And it allows you to, well, one, it gives you a climatology of what is the average last spring freeze at various numbers, not just 32, 28, we go to 25, 20, and all the way up to 40. But what happens in the spring and the fall? So you have an idea in your area what an average is and kind of a range of that. But then you can also look at how these are changing in the spring and the fall, which is really the more powerful, even more powerful part of this that I really like to show people. So this is what you'll see, and then the up at the top you'll see first fall freeze, first spring freeze. And then we also include the growing season, because that's the other part we're trying to get at, is what our growing season looks like. And then on the right-hand side, you can change what your temperature is. And then the scale, it's a little bit small, but the scale shows in the far upper right-hand here of what those numbers look like. So we'll jump through this. And I just threw this in for a comparison standpoint. This is also, you can see what the averages are, but you can see what the trend is, how the changes are occurring on each of the regional areas. I should also pause and say, for those of you attending live, I'll happily answer any questions anywhere along the way. You can raise your hand, or you can type them in the chat, or you can just take the mic off and say, hey, Todey, I got a question. I'm more than happy to do that anywhere along the way. Feel free to shout them out. So anyway, the upper graph here that we're showing is the first fall freeze, and we're using 28 as our fall freeze in this case. And in the bottom is the last spring freeze, and we're using 28 in this case too, because that's the most impactful for most row crops. And basically what it's showing here is the browner areas, the darker the color is, the later the first fall freeze is becoming. Or in the lower graph, the darker the colors, the earlier the last spring freeze is coming. Now, there are some scattered areas here, like parts of Iowa and parts of northern Illinois, southern Wisconsin, where the fall freeze, and this is data since 1950 to the present, where it's showing as not necessarily getting any earlier. Or getting any later. It's actually slightly earlier. And there's some local differences here, and we fully understand that. So that's why we built this. So you can go look at your area of what this looks like. Now, the other thing about this, you might say, well, what station is this? This is based off a data set that is used. It does use station data, but it grids out that station data so that if we have any missing data from a station, or if a station is moved or something, it kind of covers up those issues. And that's part of the problem we have when using an individual station. So it's not tied to an individual station. The idea is that it covers the whole area roughly. Each parts of counties will vary a little bit differently based on topography and some different things like that. But this is the real power of this tool, to be able to look in, and you can even click on each county and then you get more details about what that county is. So I invite you to use that. If you have any questions about that, I'll be happy to answer them. But I just wanted to share that with you. And a couple other things that are really interesting that we've found, and we need to do some more work on this, is this trend varying by location. The other thing that does show up too is some of the spring freeze data. There's very much an influence of being around the Great Lakes. You can see some of these stations around the Great Lakes that are the trend is a little bit different. So it's kind of interesting to see some of those differences there, and a little bit of something going on in Iowa here. We're not quite sure exactly what that is, but there's generally, there's a general trend that we can see pretty well in this whole situation. Okay. All right. Now that we've introduced you to that, and if you ever have any other data needs or tool needs, or people are trying to make this decision, can you provide something for us? Feel free to reach out to us. We are happy to help provide something, or in some case, if something doesn't exist, then we'll work with some of our partners and see what we can do to try to come up with that. Okay, now moving on to current conditions for looking ahead. That's always where we start, is where are we right now? What is our current situation? Where have we been recently? Because that always needs to set the stage for where we're going ahead. Well, why do we need to do that? Well, one, if we're very wet, and it indicates we're going to be a little bit wetter, that's a real problem. If we're very dry, which most of you can figure out we probably are, being a little bit wetter is a good thing, but maybe not as good as we need it to do. So always a good context, and always location specific. That's the important part too, is your mileage may vary, because a lot of this varies by what your local conditions are. Interestingly enough, I just did a talk yesterday with a group mostly from central Iowa, some in south central Iowa, and in a place where I thought soils had recovered some. I knew they weren't great. I asked people to raise their hands, and the general consensus was we're okay at best to really not great still. So I was surprised about what people thought about that, and I know that's not even the worst part of the state. So anyway, moving ahead, looking back the last 30 days. Okay, upper left-hand side is the total precipitation. And again, this is contoured out over the whole north central US. And then on the lower right-hand side, the percent of normal precipitation. Okay, and these and a couple other maps, the darker the red, the drier the conditions are, the hotter conditions are based on temperature. Or if it's more of a purple color, blue to purple color, it's wetter in this situation. So here's the total precipitation last 30 days through January 16th. If you do that compared to average, you see where there's been a few storm systems that have produced above average precipitation. That area from Colorado, Nebraska through southern Minnesota, a little bit through central Iowa, and some along the Ohio Valley have been above average the last 30 days. But you still see lots of area that, despite the fairly active pattern we have, still drier than average over the last 30-day period. We know that we've been very dry, had drought conditions last year, so we need some recovery. This idea that we're not getting a lot of precipitation is kind of a problem overall. And then even when you look at those areas that have had above average precipitation, we go back now since October 1st. We're not even looking at last growing season. We're looking at since October 1st, that time when we start getting moisture back in the soils. Again, total precipitation, upper left-hand side, percent of normal, percent of average on the right-hand side. And you see that wet area really isn't that wet anymore. A little bit above average. The greens are a little bit above average, about 110, 120%. So that's good, but that's still not enough of what we need in some cases. And you see some areas, say, western Kansas, Nebraska into western Iowa, still less than half of average, 70% or less than half of average, some worse in western Kansas, and some areas in the eastern Corn Belt that are less than half of average also. And it's this eastern Corn Belt area, if people were watching the shipping issues on the Mississippi River, it's that eastern Corn Belt area that really kicked in the problems we had on the Mississippi in the fall. We've had some longer term drought going in the Missouri River, and then we were fairly dry on the Mississippi. So, the Missouri, by the time you got to where the confluence is down in Missouri and Illinois, the Missouri is contributing some. The Mississippi was a little lower, but not terrible. But by the time where the Ohio hits it down here in southern Illinois, at Cairo, Illinois, actually the Ohio is contributing 60% of the water on average at that point. So that's what really kicked in the problem, is the lower Mississippi was doing okay because it was being fed by the Ohio. Dryness in the fall really kicked in the fall in the Ohio River Basin, and that's why they had the real problems that they did. Now we've improved, and things seem to be back to being okay. I don't, we don't have a lot of water in the Mississippi, but at least we've improved the situation. Obviously, if we've not had a lot of rainfall after last year and during that recharge time, our soil moistures are going to be at best a little low, if not very dry. So what I'm showing you here is two soil moisture models. We don't have widespread measurements of soil moisture in the ground, so it's these models aren't perfect, but they give us a good general idea of what's going on. If you want to look at more local, we'll have to figure out some other products to have a look at that and actually do some measurements. For people in Iowa and Northwest Iowa, ISU Extension, the folks up there still go out and they take some soil moisture cores. They go out and actually put a probe in the ground, take the soil out, go dry it, and figure out how much water is in the soil. Been doing this for a number of years, and what you would expect to see, well, one, a full soil moisture profile there would probably be 10, 11, 12 inches of water in a 5-foot profile. But this time of year, the profile is not full. The average in the fall is 6-ish, I think, plus or minus an inch or so, depending on where you are, 6 inches of water in that profile. So you're partially full, but needing more in the spring. The measurements they took up there at a number of different places, the best were they had a couple inches of water in the 5-foot profile. The worst, they had a couple locations where they had like a half inch of water in that 5-foot profile. So they were going to need another 10 inches of liquid to get in the ground to be able to get back up to a full soil moisture profile. And that's a problem we've had with these snowfall events. I'll show you with frozen ground, that water is not getting into the profile. It's running off, but it's not getting into the profile. So just to touch on the two maps here, showing you generally the same kind of pattern. Now the scale here are percentiles. Basically, numbers that are down here in the red to brown would be driest on whatever period of record you're looking at. If you're up in the blue, you're looking at wettest on the period of record. So, out in here in California, obviously very wet from the recent rainfalls, but that plains area that is very dry, up into the northern plains, very dry. Eastern Corn Belt also fairly dry. The models may be overdoing this just a little bit, but still quite dry in that area. That area from Missouri, parts of Iowa into Wisconsin, things have improved somewhat. I don't think anywhere is too wet at this point, but at least we've had a bit more moisture in the profile. So basically, the short answer is the water's been good for the overall drought, but soil moisture is still quite short in a lot of places. Be very dependent on spring precipitation once we get frost out of the ground. So that's going to take a little bit here. Okay, one other piece of information that we include just to share also that we don't talk enough about in the way of assessing drought or how much water is being used is how much water is being taken from the soil used by the crop and evaporated into the air or transpired through crop growth into the air. We're doing some work on that with some folks about trying to quantify this a little bit better and be able to show this on an ongoing basis. But I'm just showing you this graphic, and if you wanted to go look at this, this isn't an actual number of how much water was removed from the surface into the atmosphere, but it puts it on a scale climatologically that the darker the red or the brown would be like a category of a D3 drought. This whole area centered on Nebraska, extending into South Dakota, Northwest Iowa. The amount of water going away from the surface some people call it the atmospheric thirst, would be a D3 category drought, whereas surrounding it would be D2 category. So basically, the atmosphere has been very dry, a lot of sunlight, a lot of wind is pulling water out away from the surface. So not only are we not getting enough water on the surface, but then crops and things are growing and using water from that surface to remove it. Okay, let's jump through these. And then, I mentioned about soil conditions. Let's touch on those real briefly for what we're looking at in the way of soil conditions here. Um, Iowa soil temperatures are, what I want to focus on here are the numbers that are in red. These are actual measurements at 4 inches. So that Northwest Iowa, generally soils are frozen at 4 inches, kind of a transition area through the north, southwest, and northeast part of the state. And then the southeast part of the state, we are not frozen at 4 inches. That does vary a lot based on, what the current temperature, what the cover is. We've got snow over northern Iowa, so that's helping to protect that somewhat. The warmer temperatures in the southeast have been able to warm that up overall. I did note I didn't include a snow cover map, just for completeness here. But then to look at the overall profile and what's happening regionally, what are our frost tips? Are we frozen, and where are we frozen? So we're seeing that we don't have as much data on this, but generally the idea is northern Iowa to the north is probably frozen, though the frost depth in a few places here is not very deep, or not there, largely because we've got snow cover, so that's insulating the ground, and then heat from below is able to help keep the ground thawed, and any cold at the surface, and we haven't had that much cold here recently anyway, is able to that it doesn't cool much from the surface. So we still do have some frozen profile in here, that even though we're getting some water on the surface, it's not going to be able to get deeper into the profile. Okay, after those pieces are thrown together, what's our current situation on the US Drought Monitor? Again, a reminder what this product is and what it isn't. It's a snapshot of where we are right now, of drought conditions across the country. Anything that's in white is not considered any kind of drought issues whatsoever. Anything that's in yellow is considered D0, abnormally dry, but not true drought conditions. The true drought conditions are D1, moderate drought, which is the tan, all the way up to the D4, exceptional drought, which is the brownish color. So we've, over the eastern U.S., we're not too bad. The eastern Corn Belt, we've improved some recently, with some rainfalls. Still areas, and we'll focus on Iowa here in just a bit. Areas from Iowa out in that plains where we've, still have the very dry conditions, lots of drought in this area, lots of winter wheat issues, poor establishment in the fall, poor establishment for cover crops, for people doing cover crops because of the dryness. Though, some places I did hear, they were able to at least germinate. Even a little bit of water helped them germinate and get going. But winter wheat's the one we're most concerned about right now, in rangeland, waiting to see what recovery of rangeland is. And I mentioned those areas out in California. We've seen some improvement in the drought out there because of the massive rainfalls that they've seen. Now you can zoom up and you can look at different regional views. I zoomed up into Iowa just to get the Iowa view here. This is for last week's map as of January 10th. The new map is being created as we speak and will be released it's always released on Thursday morning, valid for Tuesday morning. And why do we do that 2-day gap? Well, we have to set an endpoint, analyze the data, put it in context, make recommendations to the National Drought Monitor author, who puts the pieces together and draws the map. So situation in Iowa, those rains have improved the situation from south central to northeast and east central. We still do have some drought conditions in the southeast. We haven't quite enough rainfall yet. And we have had a little bit of improvement to the northwest. But again, as I mentioned, those really dry conditions up there, really hard to make much inroads. And with the frozen soils up there, really not going to help out the overall soil moisture profile. The U.S. Drought Monitor also has some other products. I wanted to share some other products with you overall. They do have some change maps on there, and this is the change map over the last 4 weeks. Well, as through through the end of December. That there's been a little bit of worsening in the eastern Corn Belt, a little bit of improvement, but not a lot of shift. And we don't expect a lot of shift in the middle of winter, because even when you have larger snowfalls, the total amounts of water, even in larger snowfalls, aren't that large comparatively to some of the deficits we're dealing with. For example, say a 10 to 12-inch snowfall is probably going to have an inch of liquid in it. Now, that inch of liquid is good, but when we were talking about a soil moisture profile being down 6, 8 or more inches, 1 inch, is nice, but it still doesn't fix the whole situation. And then the lower right-hand side, the change over the last 24 weeks, the last 6 months, a lot of worsening that we saw in the latter part of the Corn Belt in the fall, or in the growing season in the fall. And then one other thing I wanted to show from an overall perspective was they do have some time series, and you can go take these all the way back to the beginning of the drought monitor, which was around the year 2000 was when this started. And then, this is the top one here is the North Central US, the North Central states, basically the Corn Belt states, of the changes in the drought monitor over time. And then the bottom one is the Iowa percent of the various categories 2000 to the present. And, showing you that, the drought we're in right now, from a total severity standpoint, is not quite as bad as we saw back in 2012. We had a lot more coverage of a lot worse drought in 2012. But an extended period and the percent coverage for the North Central US and Iowa is on the order of what we saw back in 2012. So, and part of this didn't kick up until after the end of or towards the end of the growing season. So that's why the overall impact has been somewhat limited, but we're going to carry over some of that impact till next year. And that's what people probably want to know, how much we're going to fix, how much we're going to help that situation. Well, we'll talk about that here as we go along. And let's just jump through these here. Okay, now we're going to touch on a couple trends real quickly because, I needed to build that story to help understand, okay, where we are, what things do we have going on that could help us or cause more additional problems. I just wanted to include, one of the things in our overall trend, even though we have severe drought, is that overall we are getting wetter. Again, this is a graphic from the last National Climate Assessment. National assessment of what's going on for the climate and the impacts of it, showing what's going on in precipitation since the beginning of the 20th century. The areas of in green are the darker the green, the bigger the increase in precipitation. So again, we have had overall increases in precipitation in our region, and a lot of that is spring. So the trend would be in our favor towards getting some improvement this spring just based on overall trend. So I'm holding that out as a hope for you. Unlike when we compare to what's happening in the southwestern U.S., where the trend is quite the opposite way, the overall trend is towards drier in the southwestern U.S. And then just a little look at that, what that means for what happens in Iowa. This is averaged over the state in the time period March through May, that 3-month period, that planting time. And then, so each of these dots is each year, and going from 1895 until I've only got 2020 in this one, but gives you kind of an understanding of what's happening. A lot of variability year to year. And you've got some periods like the 30s here, and some of the wetter periods we've seen in the 90s. But we have been overall wetter, especially when we look historically of what's happening. And some years very wet, other years just somewhat wet, not many dry years overall. So that's something we can hold out, that there, the trend at least is with us right now. Now on the downside, I'm going to skip over this and show you for the Storm Lake one. Something we are seeing on the offside is that that wetting in the spring is being counteracted by some drying midsummer. So the graphic I'm showing you here, this is from Storm Lake, Iowa, which is in northwest Iowa. And if we looked, throughout all of most of northwest Iowa, even to parts of central Iowa, you'd see this. So this is data from the last 30 years, called a climate normal. When we compare to average, most of the comparisons to average that you hear are comparing to the last 30 years, ending the last, the end of the last decade, so 2020. So this is data for Storm Lake, 1991 to 2020. The lines here are the average temperatures by month. Red line is the average high by month, January through July and then to December. The blue line is the average low for each month. So again, the same kind of pattern. And then the brown line is the mean for each month. So warmest in July, coldest in January, December to January, which we all know pretty well. Then the green bars are precipitation. So the temperature scale is on the right-hand side, precipitation is on the left-hand side. what's happening in the way of precipitation here. So, this follows along with what we see throughout most of the upper Midwest, in that May to June or early July is the peak precipitation time, and then we start to fall off. At least we used to. Now, something that has shown up in the last 30 years is we're seeing some midsummer problems in the way of precipitation. This shows up quite well here in July. June is our still peak time, like 5.3-ish or so inches, average inches of precipitation in June. But then that falls off to less than 4 inches average precipitation in July. Well, why is this a problem? Well, if you think about crops that grow, primarily corn, somewhat soybeans, what is the peak time when they need water? Well, the peak time when they need water is midsummer, because that's also the time when they're most actively growing, transpiring, and tasseling for corn. And that's also the time of the most heat. So the atmosphere is trying to draw more water and make the crop use more water at that time. So if that's a peak water use time, but our precipitation is falling off, that's one of the pieces of Midwestern ag that has always been our advantage, is that, that peak time of year when the crop is growing, we're still getting rainfall. If we're getting this shift midsummer to a lack of rainfall, that's going to start hitting some of our crop growing areas very, very, very stiffly. So there's probably some thoughts to be looking ahead as to what we're doing in the way of cropping and the kinds of things we're growing and how we deal with that. Number one, what it says is make sure we're taking care of our soils. The main way we can keep water in our soils is make sure our soil structure is there. It's not compacted. We keep as much organic matter in place as we possibly can to maintain water in that soil. When we lose organic matter, we lose compaction. We don't have an ability to store water, hold water in that soil. So when those dry periods come, we don't have the water in the soil, or the plants can't reach it to make use of it, is part of our problem. Some other things are, are there ways that we can shift our cropping system to deal with this? I had a guy at our talk yesterday, I mentioned Hank, and he mentioned this. He said, I'm trying to think about ways of growing corn earlier, doing a shorter season hybrid and moving corn earlier in the season so that we're past that tasseling point during this time when we dry out. And then maybe cover crop, or, maybe somewhere down the lane, we can even consider doing some kind of a second crop if the growing season gets long enough. So some kinds of things we need to be thinking about and looking at in our management practices. Okay, one other issue that has shown up at some of the crop advantage series I've been following this talk, so I wanted to throw this in. Tar spot has been a problem showing up in corn, and part of this is related to increased humidity, more moisture in the atmosphere. Even in years when we don't have as much rainfall, we'd expect that during heavy rainfall years, but even when we don't have heavy rainfalls, we're getting into issues with more humidity in the air, leading to more dew formation, more disease issues from a crop standpoint. But the other thing that humidity does, and especially if you're dealing from a dairy standpoint, is that more of our heat episodes are not so much absolute high temperatures, 100, 105 degree temperatures, but they're more maybe 95 with a high dew point. So it's not quite as hot, but you combine the warmth with the moisture in the atmosphere, so we're not able to cool. Humans, livestock are not able to cool. We have high heat index issues. So this is something we're seeing more of. And then even if we don't necessarily get that high during the daytime, that moisture doesn't allow the nighttime temperature to cool as much. So that combination is leading to longer stress period on livestock, which is leading to fertility issues, gain issues, productivity issues, or even in some cases leading to mortality. We had an issue again show up this year in Kansas, where we had a couple thousand head of livestock, I think, with a quick warm up in May that livestock hadn't quite adjusted to yet. Fairly humid conditions led to some mortality, and that's not common, but it is around, and we've had a few cases we can point to where we've had some major livestock losses under these increasingly warm and humid conditions. Okay, Now, if we've gone through that, talked about some trend issues, let's go ahead and look at what we can say going ahead for us from now up until into the growing season. Okay, some of the things that we use when we look at climate outlooks. Okay, I'm going to show you some products from NOAA's Climate Prediction Center. But the basic things that we look at are what's going on right now, El Nino, La Nina status. You've heard a lot about this before, but it's not the end all and be all of everything, but it does help us give us a guide for what may be coming. And La Nina is starting to weaken. That is going to take away some of our ability to see what might be coming. There are other atmospheric oscillations and ocean oscillations. Some of the atmospheric ones aren't always forecastable more than a few weeks in advance, so it's hard to tell much about them until it's near about ready to happen. For example, that very cold outbreak we had right before Christmas, there was a shift in what we call the Arctic oscillation, which is related to temperatures over the pole being able to move down into the mid latitudes, and they're very much related. When this oscillation shifts, we can see cold coming, but we just can't see it more than a few weeks ahead of time. So we can see it, and then we can start talking about it then. Also trends, and then computer models, which always have to be interpreted because we can't, especially far out. Computer models may not be always correct. Okay, first off, I mentioned La Nina. What's happening with La Nina? We are nearing the end of, I think, finally the end of a near 3-year La Nina episode. La Nina becomes more apparent, and El Nino becomes more apparent most times in our winter. Sometimes it's apparent into our summer. But started 3 years ago, and we've had 3 years back to back of La Nina episodes during the winter. Last couple years, we thought they were going to be ending, but it ended up not happening. Does look like it's going to go away this time. So the area we're looking at here is the Pacific Ocean. Central Pacific and along the equator here, this area in blue. The scale over here on the right-hand side is degrees Celsius and difference from average. So the area in blue is colder than average water, indicative of La Nina. As the graphic goes along, you see that the anomaly or how much colder seems to get smaller, not as cold, and the area covered is becoming smaller, all indicative of that La Nina starting to weaken. It's going to hang with us for a bit longer, but it looks like it's going to be gone within the next couple months and not be influencing us from spring into summer, it looks like. And in fact, we may be shifting towards the opposite phase. The opposite phase of this is warmer water called El Nino. We thought maybe by next winter. Some of the most recent projections say maybe by end of summer, early fall, we could get into El Nino episodes at that point, which does give us some things we can talk about looking ahead in the outlook. So we'll talk about that here in just a bit. So just to kind of, I mentioned about the last 3 years. The graphic here shows from 1950, so 1950 to 1970-ish, 71 to 91, 92 to 2012, and then 2013 till the present. Where the peaks of these are, where the oranges are, that's warmer than average waters. Those are El Nino episodes when they're above the red line. The opposite phase, the bluer and below the blue line, they're La Nina episodes. So just showing you there was a 3-year period back in 54 to 56 where we had one. Here 74 to 76, there was another one there. The one around 2000, we were close, didn't quite get it to 3 years. So here we are the last 3 years and look like we're probably, so the last 3 years back to back is not unheard of, but it is a little bit rare. So it doesn't mean that much more different. It's just an interesting episode. Okay, looking ahead for where we're headed then, I mentioned about El Nino maybe going away. This is a graphic that shows what the probabilities are of the episodes happening. The scale on the bottom is 3-month periods: December, January, February. MAM is March, April, May. JJA is June, July, August, middle of the growing season. And then the bars on each one of those give you the probabilities of the blue bar is the probability of La Nina, gray bar is probability of neutral, and then the red bar is the probability of El Nino. So you add the 3 bars together, they end up at 100% because you're going to be in one of those 3 phases. So, where we are right now and in January, February, March, likely, we're going to be La Nina January, February, March. But then the gray bars become the most probable all the way into the early part of the growing season. But then you see the El Nino chances gradually build, and it's the more probable one by July, August, September, October. So there's some skepticism as to that we transition that quickly to affect the growing season. It might, but it looks like more like by fall, we may be back into El Nino conditions. And again, it's not everything, but it does influence some things we can say about those times of the year. So the one thing I want to point out here, if we're in neutral conditions, these graphics are what are called box and whisker plots. Just to show you something, not to go into great detail about it, but this breaks down, precipitation, what is likely for precipitation during El Nino, neutral, and La Nina conditions for March, April, and May for Iowa. So that actually neutral conditions, there's a wider range. You see a pretty good range of possible conditions, but the average is actually higher during neutral conditions than El Nino or La Nina conditions. So that is an advantage that we may be wetter in the spring. Again, some good news. And then June, July, August temperature distribution for El Nino on the left, La Nina on the right, and neutral. Not a lot of difference here, but basically saying that if we get to El Nino conditions by summer, El Nino conditions in the summer generally are better for us. Temperatures are a bit more moderate, a little bit better chance for precipitation. So from a drought standpoint, El Nino would be good for us overall. So that's why we're watching very closely what could happen there. Okay, we're going to walk you through the current set of outlooks right now to give you what NOAA is saying. As we record this, we're a day ahead of the new ones being released. They're released, the long range ones are done once a month on the 3rd Thursday of the month. I'll show you where you can find out more information about those here in a few slides. So we're going to walk through the 6 to 10 day and 8 to 14 day. They are updated daily. Every day there's a new one of them comes out, gives you a good assessment of kind of where we're headed, what we see coming up, at least in a couple time periods. There's a monthly that's updated twice a month, and then longer range agains are the 3rd Thursday of the month. Now, these are general purpose maps supposed to be for a wide sector audience, not specifically built for agriculture. So if you want to get an ag emphasis or an ag view on what these mean, you can go to our website. One, we have them on our website. 2, you can go to our website and sign up that you can get an email when we update those. So we'll show you where to do that in a little bit. Okay, next 7 days. What are we looking at for the next 7 days? Mentioned this big system coming across the central U.S. A good chance of an inch or an inch plus through Nebraska, maybe a little less than an inch over to Iowa to the Great Lakes. So a decent amount of moisture from this. A lot of it's going to fall as snow. Some is going to fall as rain. There's actually going to be some severe weather down in the southern U.S. as there have been recently, and then the eastern U.S. is going to get more out of this. Then we go a little bit quiet after that point, but that's okay given the recent precipitation. Now, then the rest of these are going to be probability maps now. And on the left-hand side is going to be temperature. Right-hand side is going to be precipitation for all of them. Okay, so 8 to 14 day outlook puts us at the end of January, an increasingly more probable turning period of colder. Get into late January, early part of February, more focused on the Western U.S., but here in the plains and upper Midwest, looks like we have a fairly likelihood of being colder than average. So this could be fairly cold again. It's hard to give too many details, but it looks like the period is going to be colder. So you'll have to keep an eye on some things at that point. Could impact livestock if we get too extreme. On the precipitation side, the probabilities are fairly small. The light green is slightly increased chance for precipitation above average for this time of year, very slight, and the gray area is more near normal. So not much more active than we have been, but not dry either by any aspect. Now, I would usually show you the monthly one, but since we're in the middle of the month and the new one will be issued tomorrow, I'll decide to show you the week 3-4. So this takes you into early February, and you see more of that cold, more likely going to focus on the Western U.S. and Northern Plains. From a precipitation standpoint, more Ohio River Valley and west. The west can use it, so that's a good thing. Up in our area, not a whole lot to be said. Some dryness, catching parts of Kansas, areas that do need more precipitation. And then this is, again, the last 90-day outlook. I don't know what the new outlooks are going to look like at this point. I don't think they're going to change an awful lot. So this should give you a kind of a gauge for what's going to be happening given La Nina conditions, and we interact with these folks and kind of know what they're thinking in the way of the background. So I'd encourage you to check out the new outlooks when they're released on Thursday the 19th. There is a webinar where we'll be talking about these too. Okay, so the seasonal outlook, January, February, March. The northern plains have a slightly better chance of being colder, and I think that'll probably continue in some form. Southern U.S. and eastern U.S. have a better chance, slightly better chance of being warmer. Not a whole lot to guide us, enough to guide us one way or the other here in the central U.S. From a precipitation standpoint, what we expect to see happening is a very La Nina looking like condition, like the temperatures are. Eastern Corn Belt has a better chance of being wetter, which we've been so far. Even into eastern Iowa, we've seen more improvement. Western Iowa not, because western Iowa and into the plains have a better chance of being drier than average. And that's kind of how it's worked out too. A little bit of differences, but generally this has been fairly La Nina looking overall from a precipitation standpoint. And then northern plains, a better chance for being above average there, just a small increase in that likelihood. Okay, now I'm jumping ahead to March, April, May. So this is spring, March through May. And La Nina going away does influence the outlooks that we don't have as much certainty or more likelihood of some different things. You're going to see a lot more white, which is the equal chances. So temperature-wise, equal chances on white for March, April, May. Mostly equal chances for precipitation also, except for the Eastern Corn Belt. So Eastern Corn Belt, again, has a better chance of recovery. We might have some areas that could get a little wet. I don't think we have any place that's too wet at this point. So I don't think that's going to be a problem. The only downside of this is that we do need precipitation throughout much of the plains and upper Midwest. It's not saying that we won't get it, but it's not giving us the hints that we are going to get it, that we really need to have happen. And then we'll jump ahead for where we are with June, July, August. We'll touch on these again soon. Trend is towards slightly warm in the summertime, more driven by minimum temperatures than maximum temperatures. And then a lot of EC equal chances, because without El Nino or La Nina, our opportunity to say much about precipitation several months in advance is fairly weak overall. Okay, let's kind of summarize our situation here, where we are. The rest of winter, we're getting some cold returning later in the month. Climatologically, we're at about that peak, the coldest time of the year. So some cold returning is not a surprise. We are having the storm come through. We go a little quieter for a while, but the latter part of winter is actually more active climatologically. So I would expect us to start getting more active again as we get into February. From a spring standpoint, we're going to have dry soils over most of the Corn Belt. It should allow you to get out in the field early if you're trying to do something like that. From a rangeland, pasture land perspective, we may not get as much water as we hoped or need, especially the further west you are. Western Iowa out in the plains, I'm concerned about pasture rangeland conditions. Eastern Corn Belt probably are not too bad. So we're going to continue to see drought improvement. Eastern Corn Belt has a better chance. Eastern Iowa, the better chance to improve that situation. Western Iowa out into the plains, we will probably see some improvement, but not as much as we would hope. And we'll probably see some carryover drought issues into the growing season. Then jumping to summer, what is our summer looking like? Again, we can't give a lot of detail. I think it should be better than last year. We've got 2 years basically with some drought issues. I think we should be better with the weakening of the La Nina. And just, we tend not to have longer drought periods in the Midwest, so we should have improvement. How much better is a real problem, a concern for us here, so we'll continue to watch this. Some drought issues will probably continue into parts of the Corn Belt and Plains. I just don't see us eliminating all of it. We will generally get better, just not enough in some cases. La Nina is likely going away. We could be into El Nino by next winter, or even outside chance by the latter part of the growing season. So that would provide us some bonus, some benefit if that were to happen. So that would help improve our situation chances. Okay. Last couple things. I mentioned the third Thursday of the month, we always do a webinar with partners from NOAA, state climatologists, regional climate centers, et cetera. It's free. Anyone can join. You just got to go to the link and sign up to get registered. It's free, doesn't cost you anything. We also record them, and you can see the slides and listen to the recording later if you're not able to be there. You can also ask questions. You can bring questions. I'm usually there as the resident ag expert to provide some ag context along with some of the other folks. So always welcome people to be part of that. And here is our website. I do want to point out, I mentioned, we have these ag-focused climate outlooks using the NOAA outlooks to help provide some context for agricultural, the wide range of agriculture, and what we're talking about here is we're talking row crops, we're talking livestock, we're talking specialty crops. So trying to touch on a little bit of some of those to give people something to work with of what's going on and what's coming up ahead. You can find them always on our website at the link below, or you can get on our email list. And now when I say that, let's go jump to that. Here is where you can get on that email list. There's you sign, it says newsletter, but basically it's our email list. You get our newsletter when we update any products, new products, we put those out. Here's our main website. If you do Twitter, still do Twitter, I'm at Dennis Todey, or the Climate Hubs are at USDA Climate Hubs. And then here's the rest of the gang, which is growing as time goes along here. We're working on hiring some new folks that will give you some opportunities to hear from some new folks in the future. So thanks for having me. Appreciate getting a chance to chat with you. Hopefully you found something useful. If not, get a hold of me and say, hey, here's something that would be useful.
Thank you very much, Dr. Todey, on the road. So again, thank you, Dennis. We appreciate everybody who did join us live, and we'll look forward to the next webinar, which will talk about forages, high forage diets for dairy cows. Again, thank you all.